I don't even know where to look for people.
Also, I will
watching.
check.
Okay. Looks like you're live.
Yes, we are
Yeah.
live. And waiting for the clock to turn 3 p.m. and then we will kick this off.
Yep.
Great.
Yeah, I think it works on my end too as well.
That's
Great.
good.
We're all set. I'm
Yeah.
just
So how?
But we
How
can't
is-
see from here if there are anyone watching.
I can see that says live viewers 3.
Yeah.
Okay. Where do you see that?
Top left corner where it says, or maybe it's only me who can see it.
I can see it as well. Yeah, 6 now, I think, right?
Yeah. Yeah, welcome everyone. We're still waiting for the clock to turn 3 p.m. So we're just gonna hang out here for another 2 minutes before we kick it off.
I should have worn my 84 codes shirt too, I think.
You look very sharp though.
Yeah. Me too, but it was too warm today. It's like real summer here, so it was too warm to wear the sweater.
Yeah. I'm situated just an hour south from the Arctic Circle, and really we have 23 degrees today.
23.
Yeah.
That sounds like Nigeria. Let me see.
Yeah.
In nighttime.
Because I think it's 25 today in Abuja.
Wow. Nice.
Wow.
Yeah, 25.
I have 30, so it's warmer here.
And by our standard, 25 is not super warm like that, because it gets higher sometimes. Oh, there's someone from the Netherlands and they're saying hello.
Wow, hello and welcome from the Netherlands. I've never been to the Netherlands. I wish to go.
How close is it to Sweden?
Well, it's quite close. It's just on the other side of the sea, so not a big sea. And hello from France. Hello, France.
Yeah. Hello.
So nice to see all the nationalities.
Yeah.
I am waiting for someone from Nigeria to say hi. I'm disappointed.
It's actually it just turned 3 o'clock, and I think that it's time to kick this off. Are you ready, guys?
Yes.
Yep.
So hello everybody and welcome to the CloudAMQP live stream. We are thrilled to see so many of you joining us today. The topic of discussion today is Apache Kafka and RabbitMQ Streams, focusing on their differences and their similarities, as well as the optimal use cases for each technology. I am Sophie from the CloudAMQP team, and joining me today are my colleagues Magnus Landerblom and Nyior Clement. Magnus, a developer based here in Sweden, has nearly 10 years of experience in messaging software. He has previously served as a project manager for Cloud Kafka, a hosted Kafka solution. Currently, he is working on LavinMQ, our new messaging software. We also have Nyior with us, our host for today. He has been a developer advocate at 84Code for almost 2 years now. His daily tasks revolve around RabbitMQ, which involves exploring features, assisting customers with their issues, writing about RabbitMQ, and occasionally speaking about it. He is joining us from Nigeria, and I'm gonna leave the stage for you now, Nyior.
Yes. Thanks a lot, Fia, for the great introduction. And thank you all once again for joining us. It's such a pleasure to have you here with us today. Personally, I've been looking forward to this live stream, so it feels really, really good to finally be here. Like Fia had said, I'm going to be your host for today. And what that means is I'll be asking Magnus most of the questions. And speaking of questions, this live stream is generally just going to be a question and answer session that would last for at most an hour. And so I am going to spend the first half of the live stream, the first 30 to 40 minutes, asking Magnus questions that I have curated from the community and from our interaction with customers over the years. Then I'll spend the last half of the live stream asking him questions from you, the audience. So I strongly encourage you all to keep your questions coming while the conversation is ongoing. You can use the chat box on YouTube for that. Like I said, we're going to look at them later on and try to answer as many as we can. Magnus, did I leave out anything you'd like to add, or do you just want to say something before we proceed?
No, sounds good. I'm just happy to be here, and I hope I can answer all your questions. So I'm looking forward to this. It's a fun topic to talk about.
Nice. I think I'm just going to jump right into the questions and put you on the spot. Are you ready?
Yes.
Nice. So I'd like us to start the conversation today from the very beginning. Just introduce us to RabbitMQ Streams and then Apache Kafka.
Yeah, sure. RabbitMQ, as maybe some of you are aware of, is a messaging system. So it works by, you can send messages between systems. So think of it as a mailbox between services. It's built up using exchanges and queues. So what you do is you publish to an exchange that's get routed to a queue. And streams, it's a new type of a queue that fits into this model as well. So you set up a stream queue instead of a normal queue, and then you can publish messages to that. The difference is that it has different semantics that looks a lot like the semantics that Apache Kafka has as well, which is some of the topic of this. Kafka, on the other hand, it was developed after RabbitMQ, and the need for it was, they built it because they had needs for really high throughput and scalability to send an extremely high amount of events through the system. So they built it for that. That doesn't have queues. Instead, it has something called topics, which I guess we'll talk more about later. Otherwise, we have some questions from the audience around that. But both the stream queue in RabbitMQ and the topic in Kafka is both modeled around an append-only log, which means that you can only add messages, you can't remove them, which is a big change in the RabbitMQ software. Yeah.
Thank you for the intro. I think I might have some specific questions around what you've said later on. But I'd like us to focus on RabbitMQ Streams a bit before we proceed. So I think you did mention how streams were later added to RabbitMQ. So RabbitMQ has had other queue types, right? What's the deal with RabbitMQ Streams? Why were they added to RabbitMQ?
So first, just look at the existing queues, the queues that were in RabbitMQ before Streams was released. It was a queue. You put a message into the queue, and when you read the message, it was removed from the queue. That semantic is very simple to reason about. So if you consider a task, you just put the task on the queue, and when you're ready to perform task, you grab it from the queue, and then it's removed from the queue, and you can continue with the next one. But sometimes it's really useful to not remove the message from a queue. So even when you read the message, it's still there in the queue. So you can maybe read it again, or you can spin up another application to read all the same messages. And so that's what Kafka does. So you can read messages more than once. from the same topic. The same with the stream queue. You can read message multiple times from the same queue. So there are different use cases. So I think they complement each other both. So streams is not a replacement for existing queues, more than a complement. And streams, it's built on a different way, both storage and internally. So it allows for much higher throughput, which I think that maybe RabbitMQ saw that Kafka is gaining traction. We need something with the same. But that's just my opinion. I'm sure but it feels like it because they look a lot like each other. But yeah, you can get even higher throughput using streams than a normal queue as well.
Great. Before I move on with the questions, if you're just joining us, welcome and thank you for joining us. It's such a pleasure to have you. Earlier at the beginning, I said we're going to spend the first half where I'll be asking Magnus questions, but then we're hoping to spend the last 20 to 30 minutes answering questions from you, the audience. So if you have questions while we're talking, just keep them coming. Use the chat box. We're going to look at them later and try to answer your questions. Now, back to you, Magnus. You talked about how streams and Kafka would leverage like an append-only log for message persistence, right? I'm just curious, what does this log file looks like on disk? Just give us an idea of how these technologies persist messages under the hood.
Yeah, so in general, or both RabbitMQ and Kafka works by allocating one big file and storing a bunch of messages in that file. And then in order to find the specific message that you are looking for when you start consuming from the queue, in RabbitMQ's example, you must give it an offset, and that offset actually points directly into that file, so you know where the messages is. So it looks, it's kind of hard to explain without having images here, but you can see that the offset that actually points to a location in that file, you use that in your consumer as well, both in Kafka and RabbitMQ. So you give your client, give them an offset and say, I want to read the message at this offset. This actually points to the location in a file. Then you get that message back, and then you increment the offset to the next one, and you get the next message back. So it's as you say, it's quite raw when you get like real access to the file. It looks like it. So, but yeah.
This file you talk about, so in the case of RabbitMQ, did you say it's just one huge chunk of file, or is it broken down into segment files, and how does it work in Kafka too as well?
Yes, so they are both broken down into multiple files, but it's not one file per message. It's a bunch of messages in a file, and you can specify both in RabbitMQ Stream or RabbitMQ and in Kafka how big these files are. The reason they do it is because creating a new file, allocating a file on disk for each message is quite costly. So the throughput will be much, it won't be that fast. But you cannot have one big file because that affects other features of the software. So you can, both for RabbitMQ and Kafka, specify how big these segments files will be. For example, in RabbitMQ, the default size is 0.5 GB, if I remember correctly. But you can set it to bigger if you want to, or you can set it to smaller. It depends on your throughput requirements, how many messages you're sending, and how often you clean up these segment files. And the same for Kafka. I don't know the default size, but you can also specify that both on a broker level or also on a topic level, how big these files should be. So you can have for different topics in Kafka, you can have different segment sizes.
Yeah. So in the case of Kafka, I know you have topics, then partitions, right? You mentioned that earlier. Do you have a file per partition for each partition?
Yes. Exactly. So in Kafka, a topic is more or less just a grouping of partitions. So it's the partitions that you're actually working on and you're producing message to and consuming message from. So in Kafka, each partition has its own segment files, which means that if you have a topic with 10 partitions, if all partitions were to be on the same server, you would have at least 10 segments files. Probably more, because you don't clean up them right away. And the same for RabbitMQ Streams, you have per stream. So a stream is more, it's even maybe even better to compare a stream to a partition when you look at them. When you look at how they use files on disk and stuff like that.
Yeah. Okay. So now you talked about how I'm happy you discussed it a bit. How Kafka has topics and then partitions, because I find super streams in RabbitMQ to be similar concepts to that in Kafka. Can you tell us a bit more about super streams and how they may compare with Kafka as well?
Yeah, absolutely. So if we first look at Kafka, you have a topic and you set it to, let's say, 3 partitions. What you can do with that is you can put 1 partition on each broker. Let's say you have a cluster of 3 brokers, which allows you to utilize each broker, so each server, to its full potential. So you can send 3 times as much data as if there are only 1 server. So that's the idea behind partition. Here you can just have a topic and then you can add more partitions, and you can, when you add more servers into the cluster, you can add more partitions in order to scale it out. When we look at RabbitMQ Streams, when it first came out, I think it was around maybe 3 years ago, if I remember correctly. They only had streams. It was only 1 stream, so only on 1 server. And that's quite a limitation, because if you want to go to extreme throughput, you need to be able to scale horizontally. So by horizontally adding more servers to the cluster. Because adding just more memory and CPU doesn't make it always faster. You need more servers. So and then they come up with the concept of a super stream. The super stream is like a grouping of streams. And it allows you to put 1 stream, 1 or more streams on different servers. So if you have a 3 or 5 node cluster, you can put streams on different servers in the cluster, which allows you to have more throughput. And the grouping, or so to say, the handling of which stream are on which server and which stream to write to or read from is all handled by the client. So SuperStream gives you like it looks, for the client, it looks like 1 stream, but it's actually multiple streams on different servers. So it's really quite fascinating to work at, and it works really well.
I'm just curious, is this super stream like a physical entity, or is just like a logical grouping of these streams?
Yeah, so it's just a logical grouping. Let's see if I remember correctly. You specify, I don't remember correctly, but you can, when you create a super stream, they add, I think it's an argument or something to each stream, so it knows which super stream or which group it belongs to. If that answers your question.
Yeah.
So you don't see if you log into the management interface, for example, you don't see like, oh, here is a super stream and here is 2 streams. You only see stream queues, and then you can go into that and you can see it belongs to a super stream, which has other streams on other nodes, for example. But you don't see, there is no concept in the broker of or in management interface, you cannot see a super stream.
how do you work with consumers when you're working with super streams? Because I saw something about this concept of composite consumers, right? With super streams and RabbitMQ. How does it work?
So for the producer, it uses the because what you want in a super stream, or most of the time you want, let's say you have a super stream with 3 streams and you are pushing data related to customers. Usually you want all the data that belongs to one customer in one stream, because only then you can be sure that all the events are ordered. So if I push messages to stream 1 and stream 2 in a super stream, I might consume them in different order, but usually you want all the messages relating to one customer or one, whatever it might be, to be ordered. So you need to be sure that all these are written to the same stream, and you do that by using always the same routing key. When you publish a message, you use the same routing key, and what it does is that it takes a routing key, produces a hash, and look at that hash, and then you see make sure that all the keys with the same hash goes to the same stream. And when you consume, that's a bit more complicated. But when you spin up one consumer, it will start consumed from all the streams in the super stream. You just don't see it, so you might get you get messages from all 3 of the streams, so from 3 different servers. You can look at if you want messages, but so you get messages from different streams, but they are still ordered for each customer. But you might get message 1 for customer 1 and then message 1 from customer 2, because that's in another stream. But for each customer, they are still ordered. And I think this is something that at least I've heard a lot in the Kafka world. You create one partition per customer because you only want one customer data in a topic. I don't think that solution scales. Might work when you have 10, 20 customers, but hopefully the business grows. If you have 10,000 customers, you'll have 10,000 partitions. The same with streams. So you shouldn't use one stream per customer. You should have one stream and put a bunch of customer data in the same stream, just to make sure for customer 1, everything ends up in one stream. On the consumer side, you can use, they have a feature called single active consumer. You can put in the stream. So that allows you to scale the consumers as well as the streams. So let's say you have 3 streams, you spin up one consumer, it consumes from all the 3 streams. And then you can add another consumer. If you just add that will continue. It will start to consume from all 3 streams as well. But there is a feature, maybe we can go into deeper later, that says that only one consumer should read from the stream to keep it ordered and all the messages in the same. But we can go back to that. I feel like we're time flies.
We let's move on from super streams a bit. But before I ask you the next question, back to the audience again. If you're just joining us, you're welcome. Hi from Brazil, hi from Nigeria here. I said we're going to spend the first 30 minutes. I'll spend the first 30 minutes asking Magnus questions that we have curated, but we're also keen to answer your questions. So while this conversation is going on, if you just notice something that isn't very clear to you, just go ahead and type it in the comments. We'll look at it later and try to answer all your questions. Back to you, Magnus. We're moving away from super streams and cycling back to something you said earlier on. I think you've mentioned how both streams and Kafka leverage an append-only log, and as its name suggests, it's immutable. You add stuff, but you can't really delete, right? I imagine a file like that has the potential to grow infinitely. So my question is, do these technologies offer some retention strategies, or just in case I want to get rid of data that I feel like I don't need anymore?
Yeah, good question. That usually comes up because first you start thinking like, oh, it's nice I don't delete my messages, but sooner or later your disk will get full. And both RabbitMQ and Kafka handle a full disk very poorly by experience. But so yeah, what you do is you can specify a retention policy, both in RabbitMQ Streams or for RabbitMQ Streams and in Kafka. And the policies allow you to specify either size or date. And the size is the total number of bytes in the stream. If the total number of bytes exceeds what I said in my policy, it will start to remove the oldest segment. Like I mentioned before, we store all messages in segment files. It will start to remove the oldest segment. And the other one is time. So you can specify only keep messages that are at maximum 1 hour, 1 day, 1 week, 1 month, 1 year old.
Yeah.
Which is kind of nice because then you can make sure, for example, if you want to only make sure you store customer data for 30 days, and then you need to clean it up. You can set a retention policy for 30 days and it will automatically be cleaned up and you cannot get that data anymore. So both of them, and you can also combine them. So maximum 1 gigabyte or at maximum 7 days. Difference is for Kafka, you specify only in seconds, or if I remember, it's even milliseconds. In RabbitMQ, you can actually specify 7 days. Then it's you don't need to calculate how many seconds it is. You can just say 7D for short, 7 days, which is kind of nice. The result is the same, but it's kind of nice. One thing to note here is you should still do validation on consumers because both of them only removes full segments. So if you have 3 segments, all of them contains data that are older than 7 days, and your retention policy says 7 days. It will only remove the 2 segments that are full. All the messages that are in the last segment that maybe are just half full, they will still be there. So when you hook up a new consumer and you start reading from the beginning, you will get messages that are older. It might be 8, 9, 10, 20 days old. Don't rely on retention policies for application logic. You still need to check the messages on the consumer. So this is only for cleanup.
You did say that the size and time policies could be combined, right?
Yes.
Is it a situation where if you combine, right? Is it that if one of them is true, then it gets applied, or both of them have to be true? I don't know if you get what I mean.
Oh yeah. It takes the first one. Only one has to be true, so it's either or both. But at least one of them. And here also makes sense to adjust what you talked about earlier, the segment size. So if you have very few messages, it makes sense to have a small segment size in order to have them cleaned up. Otherwise, you might have really old messages. If you have extremely high throughput, you will fill up a segment file in maybe, let's say, 1 minute, 2 minutes. Then it makes sense to increase the segment size.
Let's quickly move on to something else. Just tell us about how scaling is done in RabbitMQ Streams, how you can scale like RabbitMQ Streams and then Kafka. What are the options?
Yes. So for RabbitMQ, for scaling, the answer is super streams. Sometimes you might need to scale just adding more resources to servers, but usually you just grow. That's how you scale. So you can add more nodes to a superstream. I think Yeah, so that's how you scale. And for Kafka, you take your partitions and you distribute them as either just by round robin. So all servers in the cluster get the same number of partitions. But then Kafka has a nice feature where you can say that, let's say, for example, that you use your customer ID as the key, which is similar to, so all events from one customer ends up in one partition. And let's say that you have 10 really big customers that produced a lot of messages, and they end up in the same partition. The rest of the 9 partition doesn't get any data. They have, Kafka has the ability to direct pin a partition to a specific server, and you can bump that server with more resources, just that one. Or you can make sure if you have these 10 really big customers end up in partition 1, 2, and 3, you can make sure that these 3 partitions are on different servers. So you can distribute the load based on how many messages sent on each partition. So there are more fine-grained control on the scaling for Kafka. RabbitMQ is more automatic. And generally, Kafka has a lot more configuration options, both in terms of how to produce, consume, set up the partitions and everything, than RabbitMQ has. That's how you can scale. You just add more nodes, and then you can redistribute the partitions or streams to more.
So when you talk about as in technologies like this, people almost always want to know how they handle replication, just for data safety, right? What options do streams and Kafka have for replication as well?
Yes, and replication is a good thing. You should always look at replication before doing backup of data, because replication is a backup. So for RabbitMQ, like I mentioned earlier, they have much simpler controls, fewer configuration options. So what the RabbitMQ does is, if you have a 5-node cluster and you set up a stream, it will automatically add each node as followers. So let's say node 1 or server 1 is leader, the other 4 will replicate and also have that stream. So you can generate a whole lot of data inside the cluster. You can, if you want to set, I think it's called something like initial cluster size for the stream, and then you set it to 3, which allows it to only replicate data to 3 nodes, which is, in my opinion, good enough. 3 nodes. Usually 3 servers in a cluster don't crash. But you can also have 5. But by default, it just picks all the nodes in the cluster and replicate it. And in Kafka, you specify replication factor. So you can set 1, 2, 3, 4, 5, depending on how much you want to replicate your partitions or the topic. So all partitions in a topic. If you set replication factor 3, it will replicate to 3 nodes. So 1 leader and 2 followers. And it will also distribute. So these 3 servers will have like a round robin distribution on which is leader to which partition. So just set it to 3 is a good default. Then you can specify a whole lot of more configuration around this. For example, how many of the followers must be in sync before you can produce, which is kind of nice to have, but it can also affect your producers in some other ways. But as mentioned, a lot more configuration options.
I think one other thing people almost always want to know is performance. So how do they compare streams versus Kafka?
That's interesting, because all benchmarks and all benchmarks we have done on CloudAMQP and Cloud Kafka, and all benchmark I've seen is that Kafka is faster. when you look at throughput. And it does make sense, because if you look at what Kafka does, it just do this streaming topics, and RabbitMQ does so much more, and RabbitMQ Streams is something they added on later. So, but the benchmarks I've seen and done myself always result in Kafka being faster, if you look at throughput numbers. But in my opinion, throughput isn't maybe always everything to look for. It also comes with a cost. And some last one I had a presentation a while back in CloudAMQP Summit. Then we had similar resources, so same servers, same cluster size, and tried to do it. And then Kafka was around 500,000 messages per second, and RabbitMQ Streams was 400,000 messages per second. So 100 messages per second slower, but still 400,000 messages is still quite a lot. So you have to look at not only which is faster, but only is it fast enough, maybe.
So when you benchmarked RabbitMQ Streams, did you test it out with the dedicated stream protocol or over AMQP?
I used the dedicated stream protocol. Otherwise, I am not sure what the throughput is on normal AMQP client. I guess slower. But I don't have the number. But I use the dedicated stream client. The Java client. They have a Java stream perf from the RabbitMQ team.
Cool. I have a couple more questions for you. But back to our audience. So if you have questions, keep them coming in. You can use the chat box. We're going to try to look at your questions very soon. So Magnus, just tell us what should I look out for, or how should I decide whether to use RabbitMQ Streams or Kafka for my projects?
Oh, interesting question. I think it depends. I feel like if you already are using one of them, I feel like most of use cases I've seen, they try to retrofit use cases into the existing infrastructure, which makes sense. You don't want to buy a new software every time you have a new use case. So it's really difficult to say which one to use. I like RabbitMQ because it supports different type of queues or different use cases bundled in the same cluster. So you have one cluster, and then you can run your normal classic queues or quorum queues, whatever, which one you're using. And if you feel the need to have a persisted queue or a stream queue, you can just add that into the existing cluster. You don't have to add another cluster of some other software, and you need to learn how that works. So I think it makes sense to, if you're already using RabbitMQ, start using streams instead of moving to Kafka. If you're using Kafka, I would say if it works, just continue, because it's a good. It's really good software. It works well. Might be a bit difficult to manage. Same with RabbitMQ, but. So it depends. I know that for streaming and stream processing, if you're working on, if that's a big part of your business, for now I would say Kafka, because the ecosystem or all the software that it's a much more services and software that connects to Apache Kafka, and they have Kafka Connect, which connects Postgres to Kafka and to RabbitMQ and Amazon S3 or the store. So the ecosystem around there is so much bigger. And Kafka Connect plays a big part there, but also now I lost them, but all the stream processing software that connects you and do calculation and stuff. That's not, you have to do that more or less your own if you're running a RabbitMQ right now.
There are
software to connect, but yeah.
Sorry, were you talking about the Streams API in Kafka? Or?
Yes, exactly.
Oh yeah, cool. I have a couple of questions from people in the comments. I think we should take this one because he just spoke about it not too long ago. He or she wants to know what the dedicated stream protocol is.
Oh yes, so RabbitMQ supports by default the AMQP protocol, advanced message queuing protocol, and that's built for just look at the name, advanced messaging. So it has a whole lot of features that allows you to publish to different exchanges and routing keys and stuff like that. But it's not built to be high performance if you compare it to Kafka. And what RabbitMQ did when they built streams, they're like, to make use of this, we really need a protocol that has better performance. So the streaming client is just a new protocol. You cannot use your normal AMQP client. It's just a separate client that allows for example, you can batch messages in the producer, you can batch them and then send them off. So it supports fewer features, but higher performance. There are some languages that support it right now. I know that Java is the go-to implementation. That was the first one. There is one for Go. I think there's one for Rust, maybe for Python. So there's some, but it's still quite limited, but it's much faster. But yes, and the good thing here is you can use your MQP, the normal MQP client if you want to, but if you really need, if you run into, if that's the bottleneck, then you can switch to the next client. You can use the native stream client. So that's good.
It just dawned on me that we haven't really said anything about the protocol or supporting Kafka. I know we say Streams has the dedicated stream protocol and then AMQP. What's the protocol support like in Kafka?
So Kafka only has one protocol, and that's a Kafka protocol. So it doesn't support anything else. So it was built just for Kafka. So they also built all the clients around it. So it's kind of hard to call it custom because it's been around for a whole lot of years, but it's only for that one. You can implement it. So for example, you have Apache Kafka, which is the well-known one. There's another Kafka-like broker called Red Panda that implements the Kafka protocol. So you can talk to that using the same protocol, using the same client. But it's a Kafka protocol.
So basically, it's an open standard as well, the Kafka protocol.
Yes, Kafka is an open source product, and they have documentation on the how the protocol looks, and they have versioning built into the protocol. And when you look at it, you see it's built to be really performant. That's the main goal of that protocol. The AMQP protocol in RabbitMQ is built for advanced messaging, allow for really advanced routing and everything. And then the stream protocol for RabbitMQ Streams is built for performance as well.
One other question I see, and if you're just joining us, please don't forget to just ask your questions. Magnus is here to answer. One other question I see in the comments is, does RabbitMQ have something like consumer groups in Kafka?
Yes, RabbitMQ has consumer groups, but it's called, and I mentioned it, but I stopped myself, the single active consumer. So you can group consumers into a group, and then you can activate. single active consumer. And what that does is, for example, in Kafka, in one consumer group, you can have one or more consumers, and only one consumer in the group can consume from one partition. That's how we can make sure all messages are ordered. Same for single active consumer. That tells the grouping of consumers in RabbitMQ Streams that only one consumer reads one consumer reads from one stream. So you say that this consumer reads from this stream, another consumer reads from this stream. A nice feature with a single active consumer is that you, if you have two consumers on two streams, consumer 1 connects to stream 1 and start consuming, and consumer 2 connects to stream 2 and start consuming. And if one of them goes down, they are also connected to the other stream. So if consumer 1 goes down, consumer 2 will right away pick up consuming from stream 2. So you don't have any downtime in your consumers. It will just be slower because it will only be one. So if you restart one consumer, the other one will just pick up and start consuming. When the other one comes back, it will rebalance and then will start consuming from both of them again. So yes, they have groups. And that's what allows you to scale your consumers as well, because that's producing is usually fast, consuming is usually much slower, because then that's where you do all the work. One thing to think about, that's both for Kafka and RabbitMQ, you can only, if you have 10 partitions, if you have 11 consumers, one consumer will only just be idling. So you can't have more consumers than partitions because you only allow one consumer per partition. Same for consumer groups, single active consumer on RabbitMQ Streams. If you have 3 streams and 5 consumers will just be idle. They can be considered backup, but it might also be a cost that's not needed. So just something to think about.
Great. One other follow-up question I have is what are the differences in how messages are consumed and acknowledged in streams and then Kafka? Maybe while you're talking about that, you could also talk about like what delivery guarantees do they offer, how it works in both.
Yes, so I think this one is pretty interesting. If you just look at the normal queue, I think it's so not a stream queue, just a normal queue in RabbitMQ. It's quite easy. You grab a message and then you act the message when you have solved it, or when you handle the message, and then it's removed from the queue. In Kafka and also streams, what you do is you consume one or multiple messages, and then you commit to an offset. So you tell the broker, I've read message 1 to 50. And then the broker keeps track. So, okay, this consumer is now at offset 50. And when you start consuming again, if you restart consuming, you start at that offset. And here is a balance, because you have to be, if you commit for every message that you read, it's much slower. But if you read 50 messages and then commit, it's faster. Maybe 1,000 messages and then commit your offset, it's faster. But that also means that all the messages, so if you start reading from message 0 and you commit 1,000 and you read 200 more, you haven't, and then your consumer goes down, you haven't committed the last 200 messages. So when you restart your consumer, you will get those 200 messages again. So here's also a balance similar to the size of the segments. How often should you commit? If I commit every message, it's slower, and maybe you can just use the normal MQP or a normal queue where you act the message anyway. And if you commit to, if you wait too long to commit, you might have to reread some messages. So it's about a balance, what you think is good. I know Kafka also has auto commit, so based on time period, it will auto commit your offsets for you if you don't do it manually. Not sure if that's available in RabbitMQ Streams yet. All right, I don't know.
Great. And something maybe not so related is the core differences between the technologies, RabbitMQ Streams and Kafka. I know about log compaction. Maybe we could start the conversation from there. Yeah.
Yes, I think log compaction is a really nice feature. And what it does is when you let's say when the retention policy kicks in to delete all segments, it looks I'm not sure exactly how it does, but it will not only just delete all segments, it will make sure that at least one message per key in Kafka. So in Kafka, a message has a key and a value. At least one key will still be there. So instead of just remove the segments, it removes the segment unless there is the last. So so the result of this is that when you start producing messages with your keys, in the end you will have more or less like a key value store, because always you will always keep the last message based on the key in the topic, and when you consume, you always get at least one message per key. You can get multiple depending on the retention policy, but you will always get at least one. So it's more like a streaming, in my head, a streaming key value store, because what happens if you have this key value store, you consume all of them, and when the producer sends a new value for a key, the consumer will get that and will have an updated key value. So I think it's a very nice feature. I know a lot of customers used it from Cloud Kafka, and I read more. We have used it internally on CloudAMQP as well. So I think it's a really nice feature. I'm not sure if they are planning to do it on RabbitMQ Streams, if it's really difficult, or if they are, but I think it's a nice feature. So you just enable it. So instead you say, there is a setting for it. Clean up policy on the topic, and you set it to delete, which is default, so you just delete, or you can set it to compact, which means it will keep the last message for every key.
Yeah. Yes. So yeah. So there's a question, but I think the answer is yes. But I'm still going to ask you anyway. Is it possible to get a message from a stream by ID or an offset in RabbitMQ?
Can you repeat something?
Is it possible? Is it possible to get a message to retrieve a message from a RabbitMQ stream by ID or an offset?
Not by ID, but by offset.
Yeah.
So you can say when you start consumer stream, if you know the offset for a message, you can just pick that message, but you can tell the broker that you want to start consuming from that offset. So you can say start consuming from offset 100, and then you can consume one message, and you will get that message with offset 100. You can also specify. There are some like keywords that you can give to a consumer in RabbitMQ Streams, which is is it first, and then we will start reading from the first offset available in stream. You can you can say next, and then we'll start consume from the next message coming into the stream. So it will just leave all the messages that are in the stream, just a new one. So that's really nice. You can also say start reading from a certain time. So start consuming from let's say June 20th, so 5 days ago, and then we will find the offset that corresponds to that time. You can also say start consuming messages from 12 hours ago, so you can give it a time interval as well.
What happens if you don't pass an offset at all, or if you don't use timestamp?
You have to specify an offset. I think you will get an error message.
Okay.
Or otherwise it might be.
Mm-hmm.
I'm not sure. I think you get an error because I think you have to specify it.
Okay. Yeah, I hope that answered your question, Edgar. Or he said thanks. Yeah, so I guess it has. Yeah, we're nearing the end of our live stream. So if you still have questions, keep them coming. Magnus will try to answer. One thing I'd like you to comment on. I know you currently work with LavinMQ, right? Yeah. So what's the deal with Rabbit? You could tell us why maybe it was created, and maybe talk about like stream support in RabbitMQ as well.
You mean LavinMQ or RabbitMQ?
LavinMQ.
Yeah.
Sorry, I mixed it up.
Yeah, the name LavinMQ comes. Lavin is Swedish, means avalanche. So that's where the name comes from. So Lavin is a message broker. We're building an AMQP message broker that we're building in CloudAMQP internally. Been working on it a couple of years. Background is that we started building an AMQP proxy to allow RabbitMQ to handle non-persistent connections. So, for example, PHP creates a new connection every time it gets requests, sends a message, and then stop. And that forced a lot of our customers to upgrade to bigger servers because you need more resources. So in order to prevent this, we build a proxy that sits between the clients and the broker. And so it just keeps persistent connections to the broker and then handles all the opening and closing connection. In order to support that, we need to implement quite a bit of the AMQP protocol. And then we said, like, how difficult can it be to continue working and actually building? Turns out it's quite difficult, but also fun. And now we have LavinMQ. It's on version 1.2, so it's stable. It's out, available on CloudAMQP. It's really resource efficient, so it's really fast. And it does support streams, stream queue, but it doesn't support the stream client. So you have to use it with a normal AMQP client, but you get all the features of the persisted queue. So you can still consume based on topic, and when you consume, the messages is still kept in the queue. And the producer is just normally produce a message into normal exchange, and it ends up. So otherwise, it implements the whole AMQP protocol, so you can use it with a normal AMQP client. Yes.
But what's the throughput like with streams in LavinMQ, considering that you have to do everything over the AMQP protocol?
Yeah, so the AMQP protocol is slower than the stream protocol and also the Kafka protocol. As I mentioned, it's not built for speed as number one priority, even though it's fast. So with LavinMQ, I did the same benchmark I did with LavinMQ as well. One note here is that right now LavinMQ is a single node only, so it doesn't support clustering. So this isn't done with the 3 node, it was done with only 1 node. Using the AMQP, we reach 360,000 messages produced. So somewhat slower than both the Kafka and the RabbitMQ streams. The big difference is that we use the normal AMQP client. So if you're using the AMQP client right now, I feel like throughput is the biggest bottleneck. Switching to LavinMQ, and you want to have the streams without changing the client, you can use that instead and still have really high throughput with all the features of a stream queue. So
Great. Yeah.
The short story of LavinMQ. There's more. There's a lot of things to talk about there as well, but now we're focusing just on the streaming part here.
Yeah. Yeah, I know, but like I'm just curious, right? You said it's just a single node cluster. Is it ever going to support clustering at some point? Is it coming soon? Or
Yes.
I know we're supposed to be talking about streaming. Yeah.
Yes, but also part of streaming is in order to replicate data to keep it safe.
Yeah.
So yes, clustering with replication is coming for LavinMQ. Not before, after the summer.
Okay.
There is might be available already now in the main branch on GitHub, but at least as a hosted alternative on CloudAMQP, it will be available after the summer. So you can, and it will look a bit different. To set up a 3-node cluster where one node will be the leader, and the other 2 will be the followers with the active failover. So if the node 1 goes down, the other 2 will just pick up.
Great. So one last question before I allow you rest. I know you're familiar with RabbitMQ Streams and then Kafka, right? So do you have a favorite? You can tell us. We'll not judge you, I promise.
If I have a favorite, I think that Kafka is a really impressive technology, and so many companies are using it. But I really like the benefit in LavinMQ that you can run multiple type of queues. I think that's so you can run your normal queues. I really like the semantics in the normal queue, and you pick up a message, and when you're done with it, you just ack it, and it's removed from the queue, and then you continue with the next one,
Yeah.
And if you feel a need for a stream, you can just add that. So based on that, actually, I'm also a bit biased because I've worked with RabbitMQ so long, but just without considering that, just a possibility of running different type of queues, for different use cases in the same cluster. I think that's a winning concept for me.
Nice. And I'm going to stop at this point to the questions. To our audience, thank you very much for joining us. I'll hand it over to Fia now to wrap things up for us. Yeah. Fia, over to you.
Yes, thank you, Nyior and Magnus, for this session. Very informative. I believe many of us learned a thing or two about these technologies. If you didn't get a chance to ask your questions, there will be another opportunity on October 15th in Berlin at the RabbitMQ Summit, where many of our team members will be present. If you can't attend the summit, feel free to connect with us on LinkedIn and Twitter. Also, don't forget to subscribe to our YouTube channel to stay updated on the latest news. Again, thank you for listening, and stay tuned for upcoming live streams with CloudAMQP. Have a nice day.
Bye.
Bye.
Bye.